Okay, so what we're doing today is we're talking about Chapter 15. It says 16, but it's just 15. And so random variables are variables that assume different value as the result of random events. So when you think about the overall total, okay, it's a capital X. But when you think of a specific random variable inside of that overall total, it's a lowercase x. So you'll see some different things with notations, and I want to make sure you know the difference. Okay? A discrete random variable is a random variable that can take a finite number of distinct outcomes. It's very exact. There's no options. You're in this category, this category, this category. Okay? So flipping a coin, classifying people by their grade, things like that, those are a finite answer. You can't have decimal answers or other things like that. Okay? The next thing we have is we have continuous. Continuous is the other. It's a random variable that can take any numerical value and within a range of values. These can be infinite or they can be bounded. A lot of times when you measure things, this is a continuous random variable. Some examples are when you have to weigh animals for experiments or the time it takes for people to get to school. So the difference between the two is that discrete, you know what the different options are, and continuous, there can be a lot of different answers. Okay. So what we're going to do today is we're going to work with something called a probability model. And a probability model is really just a table that is a collection of all possible outcomes and the probability they occur in. So the main thing you're going to want is you're going to want to know what the event is, what the result is you get, and the probability you get. Okay? You can also write the expected and the deviation, but these aren't really used. We'll use them in the beginning when we do some calculations by hand, but once we start using the calculator, this isn't needed because the calculator will do them for you. Okay, so when we fill these things out, after you fill them out, you have something called the expected value. And the expected value is just the theoretical long-run average. It's the mean. You're taking the average of what should happen. And the way you do that is you take each value and you multiply by the probability that it has, and then you add them up. So that's just the summation. And again, you don't have to know how to do this by hand. Your calculator will do it for you once you get it in your L1 and L2. The next thing we have is we have the variance. And again, it's another tricky formula, but variance is just how much things vary. And so we find the variance by subtracting them from the mean, which is your expected, and squaring that value. But then you also have to multiply it by the probability, because this is a probability model. Again, these two formulas, don't worry about too much. Your calculator can do what you need. Okay, so here's an example. A player pays $5 and draws a card from a deck. If he gets an ace of hearts, he wins $100. For any other ace, he gets $50 or $10. For any other heart, he gets $5. Anything else, he loses. So when you list the probability model, the first thing you want to do is you want to list what can happen. Well, he can get the ace of hearts. He can get another ace. He can get another heart. Or he can get everything else. Once you know all the different possibilities, then it's helpful to go through and see what happens. So for each of these, he pays $5. So for the ace of hearts, it says he wins $100. But really, if he's paid up $5, he really only wins $95. For any other ace, it's $10. Right? But if you've already paid $5, then you're really only winning $5. And for a heart, it says $5, but you've paid $5, so these are breaking even. And then the last one, everything else, it didn't. So that means you lost $5, so you're negative. So this is the value that you get. So the first thing is the variable of what happens. The second thing is the value of it. And then the last thing is we need to find the probability. Well, ace of hearts. There's one ace of hearts in the deck, so it's 1 out of 52. An ace, there's 4 aces, but we already have the ace of hearts, so there's only 3 out of 52. For hearts, there's 13 hearts, but I've already taken one out, so there's 12 out of 52 hearts. And for everything else, I have to add these up. 1 plus 3 is 4, plus 12 is 16. So 52 minus 16 is 36 cards left. So when we originally taught it, we went ahead and we typed it in and did all the math by ourselves. But because we've already done some of those and we know how to use the calculator, we're going to use the calculator. So I'm going to scoot this up. Okay, so I need to put my values in L1 and my probabilities in L2. So stat, clear it out. You could type the probabilities in as a decimal, or you could just type the fraction, and the calculator will do the decimal for you, and that's fine. It's actually probably the more accurate way. You're not losing any decimals by rounding. Okay, so we plug those in. Now what I need to do is I go second calc, and second stat. I'm sorry, I'm having a sleepy. So you go to stat. So go to stat, go over to calc, and go to number 1. Now, my list is in L1, but my frequency is this probability. So I need to make that L2. We don't usually use an L2, but when we have the probability of events, it's L2. And so I'm missing some numbers. I'm missing the regular standard deviation, but I don't want that. I want my mean, which is my mu, which is my expected value of negative 1.34 or $1.35. So on average, you're expected to lose $1.35 per game. Your standard deviation for this is the sigma. And so you're supposed to lose $1.35 per game, but that varies by 13.8. That's the standard deviation. So now to write a summary, and you can kind of ignore this other stuff. I'll put that there. So when you write a summary for this, you need to include what to expect, what to use in the long run, and it's a good idea to talk about the standard deviation and the variability you have. So a player can expect to lose $1.34 or $1.35, because I rounded up, each time over in the long run. With a large standard deviation of 1380, there is a lot of variability. So some things to remember is when you're making your probability model, always figure out what can happen. Those are your variables. Once you figure out what can happen, figure out what's it worth. What is each worth? And then you figure out the probability of those happening. And that will help you with the model. But again, the model is just a table. Start off finding what your different variables are.